Hi, everyone. My name is Vincent. I'll be your MC for this evening or morning, depends on where you are. And also, in terms of MC, I will also be your PyMC3 MC joke. We'll just wait for like a couple of minutes before people are able actually to come in. But this will be a good time for Dana to start setup as the first speaker. But the way that this is going to work is you have between like 5 and 10 minutes. If you are very close to the 10-minute mark, I will have to start playing sound that's going to go increasingly louder, just as like a gentle hint that you are over time. But I am genuinely kind of excited about the stuff that you're going to talk about. So without further ado, virtual claps, Dana, please take it away.
Thank you. So before I start, I just want to make a small disclaimer so no one is disappointed today. If this lecture is not for you, if you always implement the most cutting-edge solution and never think about a simple one. This lecture is also not for you if you're completely blind to the client's needs. And if you cannot see the big picture, you better just move on. If business KPIs make you fall asleep, we better separate now. If talking to the product manager make you feel sick, you better just move on. And if everything looks like a nail for you, this lecture is not for you and you better move to the next lecture. But if you stayed so far, hop on board because I'm going to take you to a fascinating journey together today. So hi, I'm Dana. I'm the head of data science at PyData. I also serve as a data science advisor for various startups. And my biggest passion is solving hard problems with the most simple solution I can find. So our journey today actually starts 20 years ago when this was a very common picture, when you had to go to a tourist agency in order to book your flights. Luckily, today, you don't need to book your flight by going physically to an agency, but you can just book it online and even pick your seats. For the inventory, for the Marina world, this is how the inventory system looked like 20 years ago, and this is how it looks today. Yeah, the exact same thing. I mean, until we at PyData entered the picture. So at PyData, the startup I work in, we actually try to solve all the problems that skippers and marinas has, like communicating with each other, making reservations, and managing the inventory. But today, actually, I want to talk with you about a specific problem, the matching problem, the problem I had to solve when I first got to PyData, like a year and a half ago. So the matching problem is matching between upcoming reservation and a berthing spot. So while I was thinking about this problem, I actually realized it's kind of similar to a Tetris game. Like in the Tetris game, when you don't know which shape you're going to get next, the same is for marinas. They never know which boat is going to reserve a spot next, and they need to plan ahead. So before I reveal my algorithm, I just want to share the product requirements. The first one was first comes, first served, meaning that we actually are not running a math here. And if a boat was promised a spot, when it gets to the marina, we want to make sure it has a spot to berth in. The second assumption was that we want to allocate the specific berth only a day before a boat arrives. The reason is to keep the flexibility for the marina. So in order to meet these product assumptions requirements, I had to make some algorithmic assumptions. first algorithmic assumption was that the number of berthing spots inside a marina is a constant number because it's not an easy task to just add a pier inside a marina. Second assumption was that the cost function of my algorithm should be very flexible in order to meet different requirements for different marinas, meaning some marinas want to optimize their occupancy, some of marinas want to optimize their prestige, and some of the marinas want to optimize their maybe revenue. The last assumption was that although I really wanted to implement a reinforcement learning, I actually had only some kind of few dozen of samples when I started first to work on this algorithm. So back to the Tetris game. What if while I'm playing, I just could take the shape I just got and swap it with a shape that already exists in the screen in order to optimize the score. So this is exactly what I did in pick-a-pairs matching algorithm. Before we dive in, just want to let you know that behind the scene there is a very complex mathematical equation, but I cannot share with you today because it's a pending patent. But I can share with you all the flow. So before I share the flow, just to let you know, the blue color represents the waiting list, the reservation pool. The mustard color represents the matches. The purple color represents the available berths. So let's dive in. We'll start with a common practice today. When a reservation first arrives to a marina by phone or by email, the receptionist can just look out of the window and see if there is available berth. If no available berth is found, the reservation is rejected, and usually no waiting list is offered. But in pick-a-pairs algorithm, something different happens. Let's dive inside. So in pick-a-pairs algorithm, when a reservation gets automatically through our system, the matching algorithm tries to find this reservation a match with available berth. If no match is found, the reservation goes inside a reservation waiting list. But if a match is found, the algorithm does another optimization step by trying to swap this match with already existing matches. And if this swap would optimize the cost function, it would be made. And now boat A would be matched to berth B, and boat B would be matched to berth A. Last but not least is the following part. Actually, this was the most important part that made the most difference in the optimization process. If a berth became available, for example, if someone cancels his reservation, then the algorithm tries to match this berth to a reservation from the waiting list. If a matching is found, we're going back to the matching cascade I described before. But if no match is found, we still have a free berth, and the algorithm tries to swap it with an already matched berth. And then the new match is going inside the pool, the match that most optimized the cost function. So I think so far, I actually managed to convince you that I've created a very simple, it was made with Python, a very simple algorithm that actually meets all the requirements the product asked me and fits perfectly to our maritime domain industry. So I just want to finish with this lovely meme of Paige Bailey. Tell me the truth. I'm ready to hear it. Most of the time, you won't need deep learning. You won't even need machine learning. Thank you so much.
Thanks for the lightning talk there. Then next up, we've got Jeremy. So Jeremy, I'm going to now ask you to unmute, and if you could get the screen ready. In the meantime, what I would like to do is just share a poem that someone shared with me on Slack yesterday. Roses are red, my data is blue. Watch what I can do with an eigenvalue. Haha. Okay, I thought it was kind of clever. But having said that, Jeremy, I think you are now able to speak. Just to double check.
Yeah, sure.
Okay, yep, you're good. Okay, perfect. Then Jeremy, take it away.
Okay, thank you. It started when I've created a Python script to organize and clean mass spectrometry data from my project. In short, data wrangling. When people in the lab realized that I can write in Python, many assume that I know every single programming language there is and asked me to troubleshoot R, Python, or Bash script created by past collaborators that are meant to do similar tasks as mine. This workload got me overwhelmed, as troubleshooting these scripts could be time-consuming, and I did not have the time to do important things in research. To make myself more efficient, I combine all these scripts into one window executable software in Python called MS Organizer. Looking back, I realized that things have not been easy. This is because in academia, most of us are not trained in coding or software development. It is hard for us to write software for our own research paper. It is even more challenging to create software for others to use, as how Daniel Blocks put it, using food as an analogy. Cooking your own food is a lot easier than being a chef in a restaurant. While implementation in Python may sound simple for some, a lot of time is spent to make it user-friendly for people with limited computing experience, and I hope my sharing is helpful to those who are doing a similar task as me. So my first advice is to invest some time to learn how to convert scripts to web service or executable softwares like mine. Asking my lab members to run scripts using command line was just too hard and frustrating for them. The picture on the left was my experience in the past. Oh, Jeremy, I tried to run the script from Collaborator, but it says Python is not found. Can you help me? And then after installing Python and all its libraries, we still have to figure out how the script works and could only run it after many trials and errors due to lack of documentation. On the other hand, with a software with a decent GUI interface and telling us clear instructions on what to do, it could save us a lot of time to do the things that we need. To make this executable program, I use Chris GUI to create a simple GUI interface quickly, and then PyInstaller to convert the script to a standalone executable program. I understand that things are easier said than done, so I include Jack McHugh's blog, which helped me as a starting point to make use of these two tools to get what I need. Initially, my tool was a simple program that has a 3-page manual. However, as I add more feature requests, it has turned into this monster that requires a 30-page manual to understand fully how to use it. This made new users overwhelmed when they see it for the first time, giving comments like, "I'm scared, it's confusing, maybe this tool is not for me." To make things less intimidating, I created a cheat sheet to give an overview of what my software does, rather than just throwing to the new users my 30-page manual. You may refer to our studio website for their cheat sheet examples, PowerPoint templates, and advice on how to create these good cheat sheets. No software is perfectly free from errors and bugs. Likewise, no human being is perfect and can sometimes make mistakes. Unfortunately, people do not like Python's default errors like this because it is too technical for them to understand. It is hard from their perspective to know if the problem lies with the input data or the software. And this error below was caused because of the software trying to output the results on a file that is currently in use by the user himself. So what I did is to make the error more helpful. And it does go a long way because users can mostly solve the issues by themselves. So for the same error, I put unable to save Excel file because of permission errors. Please close the file if it's still open on your computer. Then try running the software again. I'm grateful to Sadia's blog for reminding me that the users can perform an incorrect action again and again, but it is the design's responsibility to inform him about his mistakes in a good way. And if someone comes to you and comments that your error message is unclear, may I suggest Michael's advice and tell them what changes would be helpful. This worked for me as well because it sounds less offensive to the user and shows that you're open to criticism. It also encourages users to give suggestions and constructive feedback, in turn doing the work for you. The fourth advice is to include necessary software reports to show reliability. Today, academia journals are getting more demanding with regards to software, wanting reusability besides reproducibility. They request code to be easier to install and able to run with new data and parameters as well. So here are some tips that help my code or software better to meet these standards. One, you can tag a label on different software versions and encourage users to cite not just your software name, but the versions number as well. And I usually put my executable softwares, my different versions in the release, in GitHub in release and assets. Two, you can also create a report file to store your user input parameters. And for me, I create this PDF file using Chris' example, using WEasyPrint, but there are also other examples such as Matt. Lastly, if possible, you can show pre-processing results to explain how the software calculates the final results. They are helpful when there is a need to troubleshoot for logical errors. For my case, I need to explain to a collaborator from a different science background how I generated my output values. I initially tried to explain using formulas from journal papers, but it did not work. So what I did in my software is have these optional settings to create additional Excel sheets in Ping. And then I tell the collaborators that to get this sheet, you just take the area sheet, divide by this internal standard area sheet, and then explain how these values are created. And now it comes to documentation. Documentation is important because it tells others how the software works and how it is built. It helps to prevent technical debts, especially if one taking over the software maintenance is less experienced than you. I started writing them by following some advice by Lee's article, such as including examples and quick start guides. But the mistake I made is that I put everything into one single Word file with many chapters, as you can see in the books that I have. And in the end, as my documentation starts to get longer and more complex, people find it hard to navigate and find relevant information, and in turn, hard to understand, even myself. So thankfully, I came across Devio websites that encouraged me to split my documentations into manageable categories like tutorials, how-to guides, explanations, and reference. Following its footsteps and having to clean up after myself, this is what I managed to come up with. So for the tutorials, I put it in my GitHub README. How-to guides, I mainly put them in my cheat sheets. And for the explanations for the nitty-gritty stuff like this JSON file and what is it used for, I put it in the user documentation. And for these hardcore Python scripts and their structures and organizations, I put them in the developers documentation. Lastly, a small take-home advice: create a software that gives a lasting impact, even if it's for a small group of users. When creating a software, we want to create something that impresses a lot of people or make it to a journal paper or even this conference. However, we tend to forget that the main purpose for creating a software is not to make us popular. It is to help others with their problems. A problem, no matter how small, can be as annoying as big ones. The more annoying the problem the software tries to solve, the more useful it is. The things that my software does are actually very simple, but it helps my lab members reduce the tedious workload of manually copy and pasting data and creating hard-coded formulas from multiple Excel sheets, which are very error-prone. So don't feel discouraged when you are tasked or arrowed to create a tool that does small and simple things. Instead, do these things with great love. And as this blog post from Ihresia says, if you can impact a few people deeply, they will shout from the rooftops for you. The breadth of the impact will be a matter of time. So just be patient and continue to improve along the way. And that's it. Thank you all for listening. All the best and enjoy the rest of the conference.
Okay, thanks for that. If the next speaker could please sit up, this will be, and again, I hope I pronounced it correctly, Pranav Kompally. So I will now move the cat off of my keyboard to give you permission.
So guys, this is Pranav Kompally, and I'm a researcher in VITAP, which is a university in India. And today I'll just share you guys about what I created, which is a podcast summarizer called Gargantua. And Gargantua, the name is a small nod to the black hole and interstellar because it just keeps eating a lot of stuff. So this podcast summarizer while training eats a lot of data. So can you see my screen? Sorry. Hello.
Yeah, so I can see. Now you've moved back to the Zoom, and I can see your screen.
Yeah. So the entire talk. Yeah. So sorry for the interruption. But anyway, so this talk I'm going to talk about how I leverage sequence-to-sequence learning for sending out podcast newsletters. So me and my friend Gautam wanted to create a machine which could just take podcast, do summarization, then send out newsletters to people the way you get your blog newsletters, or the way you get your New York Times or any of the news articles, and you get a proper information. So we wanted to create a review system for podcasts, of people to understand, or for people to figure out to which podcast they want to hear, or which episode they want to hear, just depending on the summary of it. So so before I go into the cream of it, this is an example of what Gargantua generated. So this is a very good podcast on being by Krista Tippett, and it's a really good one. So and then we took an episode of Naomi Shea, and then we ran the Gargantua one, and this is a summary. So I'll just pause for like 2 seconds here, 2-3 seconds here for you guys. Maybe take a screenshot or take a look at it. So this is completely machine generated, or this is completely generated by the abstractive summarizer. So how does this happen? So first, it's a very simple thing. This is the fundamental thing. This is something everyone would do, which is I take an episode and I convert it into simple text, or into a text document using Google ASR, or Google speech to text recognition model. And then after this, I take the entire text document, run it to Gargantua, and then generate a summary. So although it sounds simple, let me talk about what Gargantua is. So Gargantua is partly inspired by Pegasus by Google. I mean Pegasus model by Google, which is also an abstractive summarizer. And then this we've developed. So we've developed Gargantua for a company called as Rapid.ai, who's based in which is based in Germany. So since I can't let out the insights of what happens in encoder and decoder, but I'm sure all of you know what an encoder does. It takes sentences, or it takes input and converts them to high dimensional vectors. So this pretty much does the same. And then decoder does the same, which takes in the context vector and then decodes it to find the desired text. So what we've done is we've taken the transcript, fed it to the encoder, wherein it is converted into a physical representation of vectors by the context vector given to the decoder, which tries to generate a summary which is almost or nearby to what is written in the transcript. So, however, to train this, it's a big pain in the ass. I'll tell you why. Because data preparation is huge. So for this, we've signed the Spotify contract of getting over 1 lakh podcast episodes, and then each podcast is around each episode is around 12 to 15 minutes in it, and then the average length is around 3,000 to 5,000 words. So this is our data set which we brought from podcast. Now we wanted to generate a reference summary or a data set for the model to train or eat on. So what we've done is we've taken every episode and then we've generated extractive summaries, multiple extractive summaries using various models available on huggingface.com. And then what we've done is we've calculated the ROC score for every summary generated using extractive summary. And then for people who don't know what ROC score is a metric used by used by a lot of professionals to determine the accuracy of a summary generated by a machine. So then we've calculated the ROC scores for every extractive summary generated, after which we've taken the ROC score of the with the highest value from the summary generated, and then we've corresponded that to the particular transcript. So this we did for almost over 1 lakh or 100,000 episodes. After which, then we've come up with this concept of lock and key block, wherein the lock is the transcript and the key is the reference summary. So the reference summary is the desired output you want from the model, and then there's the transcript or whatever the input you give it, which is around 3 to 5K in words. So this entire block is fed to the model in the following manner. So instead of input text, I'm giving it the transcript to giving the transcript to the encoder, and then instead of any other summary, I'm giving the reference summary to the decoder to match it and then see if it can generate something nearby. So this training was done for over 200 to 300 epochs. So after this, what we've realized that you can do abstractive summary to a point which is good but not better. So what we did is we've gone back to square one, which is here. And then instead of calculating the highest rock score, we've taken the second highest rock score, and then and did the same process of training it on 200 to 300 epochs. After which we've got some really great results. So Gargantua training is simple, which is we take the latest, or what exactly Gargantua does at the end of the day is it takes the latest podcast episode, runs it through the model, infers to the model, generates a summary. So that is what happens in Gargantua. And after which we've created into a newsletter or an API wherein users who subscribe to a particular episode or who subscribe to a particular podcast can use or leverage Gargantua to just subscribe to the service, and then they can just wait for weekly newsletters to come, wherein the API takes in different podcast episodes and then converts them into summary and then provides it to the user in the form of an email. So this is another example of what Gargantua did in a single shot inference, which is it did not. So it took Tim Ferriss's episode, which is around 1 hour 44 minutes, which has over 15,000 to 18,000 words in it, and then it has done single shot summary and has come to this point. So this is the raw text which has been generated by Gargantua without any text cleaning or etc. So I'll just pause it for like 5-6 seconds if you guys want to have a look at it. So what we found was the results were absolutely amazing, and then this is something which every podcast creator would want to use. So this is Pranav, and thanks a lot. Cheers to Gautam Galada, who's also a co-author in this project. I'm sorry I couldn't share any project because of the confidential information, but I'm ready to share any other notebooks of Google Pegasus or the light version of Gargantua which we're about to release. Thanks a lot. Thanks a lot, Vincent.
Okay, thanks for that. It was interesting. The next speaker, hassaku, I'm going to put you on the unmute now. Asked to unmute, and that means that you should be able to start sharing your screen.
Yeah.
Very good. Take it away.
So, hi, I'm hassaku, and I'm going to talk about my open source project, improving accessibility for data science with graph sonification library. As background, I think in order to realize a diverse AI society, it is important that all people learn data science, not just experts. If there is a lack of diversity in the AI development process, the AI system will encourage division among people or have unintended consequences. Therefore, in order to realize the ideal AI society, many people will need to be involved in data science. Nowadays, it is called AI for everyone, etc. So you may have heard of it. And actually, many organizations and countries are just beginning to work on this. However, visually impaired people who rely on screen reader to navigate computers face many difficulties in learning data science because visual representations are often used in data science, as you know. Therefore, I'm developing a graph sonification library that will help people to understand data without relying on visual representation in data science. The graph sonification Python library is named AudioPlotLib. It can easily convert data such as that displayed in a graph into audio representation. You can install it via pip and try it out easily. This is an example of converting a simple series of data on Google Collaboratory.
Enter graph. X is 3, Y is 3. Leave graph. X is 3, Y is 3.
If you are able to use the mouse cursor, you can trace the shape of the graph to listen to the pitch of the audio. And you can also click on it to check the value at that position. If you are only using the keyboard, you can still use the slider to do the same thing. Alternatively, if you don't need interactivity and just want to check the graphs easily, it also has audio playback.
Minimum value is 0. Maximum value is 3. Line 1.
You can also convert multiple graphs at the same time and compare them. For example, in this way, you can check how well the linear regression is fitting.
Enter data in best fit line. Label 0 is selected. Double-click to change.
This is a sound for blue dot line data.
Label 1 is selected.
And this sound is for orange line data. So it sounds like it fits well. In addition, it has a variety of other options, such as the option to set up separate axes for comparison, like a crime graph. Finally, based on the graph sonification library introduced in this presentation, I published data science learning content for the visually impaired. In particular, for Japanese students who have the opportunity to study data science in their classes, we are working on creating comprehensive content that includes an introduction to development environment, programming fundamentals, and etc., with the cooperation of the visually impaired students. The improvement I have introduced in this presentation is only one component of unresolved accessibility issues in data science. Therefore, I welcome any feedback to help them improve those situations. Thank you for watching.
Thanks for that lightning talk. Next up is Meshva. I'm clicking the Ask to Unmute button as we speak. So you should be able to share the screen. And in the meantime, I have an interesting question to the crowd. Like, does anyone know why Teslas cost so much? You know, the very popular car, they're really popular, but they cost a lot. Do we know why? It's because they charge a lot. Yep, that's looking good. So Meshva Patel, I hope I pronounced your name correctly. You're going to be talking about data analytics in healthcare?
Yes.
Very good. Take it away.
Visible?
Yes, it's very well visible. Take it away.
Thank you. Thank you so much. Good morning, everyone. It's good morning here. And thank you so much for coming here. And I'm Meshva, and I'll be completing my bachelor's next year. And so this is a talk about how I like to use data science and analytics in healthcare, basically. And so let's get forth with it. So there are 4 main types of data analytics that we could do in healthcare sectors and in general. So first one is the descriptive one, where we identify patterns from historical data, understand the why and what actually happened. And in the diagnostic data analysis, what we do is we identify the causes, the correlation, and understand what actually happened and what actually caused the event. And in the predictive type of data analysis, we find out what is the likelihood of something that is going to happen in the future. And it focuses on correlation, statistical analysis, understanding likelihood of future outcomes. And in prescriptive type of data analytics, we find out what is the best course of action that could be taken by an individual or an organization for like strategy steps and decision-making systems. So how do we use data analytics for healthcare? So there are 4 main sectors where we'd be using healthcare and then combining data analytics to healthcare. First one is the clinical one, where we use EHR and medical images for identifying patient diseases and symptoms and understanding what, like suppose even if there is an adverse event coming up or some anomaly that is going in the vitals. And then in administrative type of data analytics of healthcare, we find out about costs, the reimbursement, how is the finance looking, how is the patient characteristics or equipment requirements, suppose if there's a predictive maintenance that is going to happen. Then the patient behavior and sentiment, we collect data from wearable sensors and social sites to identify whether some flu outbreak is going to happen in the future or it's happening right now. And pharmaceuticals, where we find out if there is like a target behavior, like how the target behavior is performing according to all the other data points that we have right now. So let me just give you a brief dive into some of the research work that was taken by me, and then we'll see how these type of data analytics is used for healthcare, basically. And the first one I'd like to talk here is outlier detection for clinical drug trials. So here I show a plot of how there's an anomaly, and then the yellow ones are the anomalies, and the blue ones are the one that is okay. It's a drug called placebo and docetaxel, where I have visualized a 3D Tresney plot for finding out the anomalies in the clinical drug trials. And the second one shows of a 2D visuals of an outlier where magnesium is being plotted about how, there are two data outliers over here. So we can find out that what actually is happening and what is the data point that is an outlier here and why is it happening. So a visualization gives a better understanding of what are the anomalies present in the trials. So that is first place where we use clinical drug trials. And to go a bit deeper inside this, the plot here is actually using isolation forest for identifying the outliers here. And the second, the 2D visuals show a simple like a plotting area where we put where we can identify the two of the outliers here. So it does not use any algorithm here, but we can see when we visualize the data of healthcare, we can see there are two sort of points that stand out from the other data. Then the second place where we can use administrative data, data visualization is in administrative department. Here is a dashboard showing that how and what is the average patient waiting time, the patient satisfaction. This can help improving the patient experience and formulate staffing requirements and scheduling for them. And it can also, if this was for a maintenance of equipment, we could identify how much there's a requirement or the shortage of equipment. And it can also, if this was implemented for like a patient, it could also help in identifying each EHR systems, means like electronic health records for each and every patient that is available and who comes to the doctor. Then we can also identify the pandemic outlook through data visualization. This could help in bringing out awareness and impactful visualization for public awareness. So this was done for COVID presently, and this would be a good thing for like organizations like WHO and UN to put forward this kind of visualization to understand what is really happening around the world. And the fourth one, it actually visualizes the patient data, where a person was tested on Parkinson's disease. People who don't know Parkinson, it's basically a kind of disease where you don't have a sort of nervous system interaction with how the body moves. Basically, your brain thinks something else, but your body does not move according to that. So it affects your nervous system. So here a patient data is being visualized about how around three activities, sleeping, resting, and moving. And the calibrations are being plotted and the vitals are being visualized here. So, and then also kind of, it helps in understanding how a patient's progress in the disease actually happens through the stages. So, and then the future work of data visualization in healthcare, as some statistics notes, that it's going to increase. So what it holds for the enterprises and the healthcare institutions is developing better tools and libraries such as open health visualizations to create a robust data pipelines. And the second thing is inculcating and developing cloud technology for accessing and sharing patient records through the health institutions. And also eliminating bias and discrimination in data, just like how we saw for outliers detection. We could also eliminate and find out the bias happening in the data and forecast it on the go. So thank you so much. If you have any questions, please do ask me. And then thank you so much. Have a great day.
Okay, thanks a bunch for that. So next up would be Ilana.
Okay, so hi, I'm Ilana. I'm a senior researcher at ZoomInfo, previously Chorus.ai, and today I'm going to talk about productizing Wav2Vec 2.0. So first, a quick intro about the company. ZoomInfo provides sales organizations with a complete suite of tools for managing every B2B go-to-market action, starting with marketing, understanding intent of companies, reaching out and engaging customers, and understanding how to have better conversations. Chorus was recently acquired by ZoomInfo. What we do is that we enable sales representatives to be the best version of themselves by unlocking the data in calls. We'll record 60 million hours of conversations this year, and we expect that number to double next year. As a conversation intelligence platform, transcription is a basic data point and one of the main focus of our research team. Most of the insights we provide are based on transcribed conversations. Therefore, it's really important because the better the transcription, the better all the results following it. So what's ASR? ASR stands for automatic speech recognition, and the purpose is to find the most likely sequence of words given a sound signal. For a long time, hybrid models comprised of hidden Markov chains, HMMs, and Gaussian mixture models, GMMs, were the mainstream speech recognition frameworks. However, recently, end-to-end systems like Wav2Vec using deep neural networks have achieved higher performance. Here on the right of the slide, you can see the architecture of a hybrid system. First, an acoustic model is used to predict phonemes from MFCCs. The model can be either an HMM-GMM model and HMM-DNN model. And then the phonemes are converted to words using a pronunciation dictionary together with a language model. Wav2Vec is one of the most prominent end-to-end systems. It was developed by Facebook. The main advantage of this model is that most of the training is made on unlabeled data. It uses self-supervised learning to convert speech audio into vector representations. And then you can fine-tune the model using labeled data to convert those representations into either words or phonemes. So deep neural networks take a lot of data to train. Labeled data is hard to get. It's expensive and it's time-consuming. Learning good speech representations on huge amounts of unlabeled data allows us to achieve high precision in specific domains with limited labeled data. On the right, you can see some of the results from the Facebook paper. The model achieves state-of-the-art performance on Libby speech, clean, and other test sets. This is what the architecture of the model looks like. First, the raw audio is passed through CNN layers to get latent representations. Then product quantization is applied to those representations. Once you have the quantized vectors, you pass them through a transformer to get the context representations. During the training, about half of the quantized representations are masked before being fed into the transformer, and then the output is optimized using contrastive loss. Then for fine-tuning, we don't use quantization. Instead, we apply a linear projection layer to the unmasked output of the transformer to get the probability distribution over the tokens. By tokens, I mean either letter or phonemes. Okay, now I'll move on to productizing Wav2Vec. What we did is that we used Facebook's pre-trained model that we then fine-tuned on our own sales in domain data. One thing to note is that Farsec, the Git, supports different language models, n-grams and transformers, and there's also an option to use Viterbi decoding without a language model. In our case, we fine-tuned the model using CTC loss with our own n-gram language model. We used the Farsec code from Facebook, but we made several adjustments in order to be able to train in our own data. And the way that we did this is by writing new classes that inherit from the Farsec ones, and then just making changes to specific functions. If you look at the code on the slide, on the left, you have the Farsec training task, and on the right is our own task class, which inherits from the Farsec one. So now first explain how to prepare the data and how we adjusted the code to work with our own data. And then I'll talk about how we dealt with one of the limitations of Wav2Vec. The model is trained on 15-second segments. For training, you need the data folder to contain the following files. The dict.ltr.txt is just a list of the tokens. So in our case, it's uppercase letters and an end of word tokens. The other files contains the data for the segmented audio, and each file corresponds to one segment. The order of the segments should be consistent throughout the files. The TSV files contain the path to the audio wave files. If you want to train, it's important that you keep that naming, otherwise you'll need to make changes to the code. Since we transcribe sales calls, our data consists of a wave file for an entire call together with its matching transcript. The first thing we needed to do was to segment the data, or in other words, to split the audio into 15-second segments and then align the transcript words to that segmented audio. This is a hard problem, and to do it, we use the Kaldi scripts. The LibreSpeech data has a separate audio file for each segment, so I had to adapt the dataset code to use specific portion of the wave file. And once again, I did it by writing a new dataset class, inherit the raw audio dataset class. Disadvantage of Tebeka compared to Kaldi is that it doesn't return warnings. Knowing what word said when is essential for a product, as we need it for speaker separation to create playlists and many other features. First, it uses a decoder from the flashlight Git, which is written in C++. Trying to get the times by making changes to the decoder itself sounded complicated and time-consuming, and we didn't want to do this, as we work mostly in Python. We found the simplest solution by hacking the first Python code that calls the decoder. So if you look at the code for the decoding function, you can see that the C++ decoder doesn't only return the decoded words, but also the predicted token per time step for the best path. We use the stride and kernel size of the convolution layers and the sample rate of the audio in order to calculate the time in seconds corresponding to each time step. You can see what it looks like in the table at the top. In the blue is a representation of the CTC output. Each cell represents one time step. The first row is just the index of the time steps. Then underneath, you can see the time in seconds that we calculated and the output token. The S symbol that you see is a blank symbol, and it's needed for CTC in order to be able to have words with repeating letters. To get the predicted word sequence, you need to collect repeated labels in the output sequence. Then you can split the sequence of tokens into words using the end of word token. Okay, so at this point, what do we have? We have timings together with word letter sequences, or what we call the word spellings. It's a language model lexicon that contains the mapping from the word to the spellings. You can see what it looks like on the bottom left. But for the purpose of transcription, we need the word itself and not just the spelling, because several words can have the same spelling, and we need to be able to differentiate words like am or am, otherwise the transcript wouldn't be readable. During the decoding itself, the best word for spelling is chosen using the LM score. So for us, the easiest way to get the words is to map the word spellings to the output words for the decoder and add the corresponding times to the decoded words. Once you do that, you're done. You have your Wav2Vec output with the timings. So that's it for today. We're about to release our own Wav2Vec model to production, and we're very excited to improve our transcription quality.
Thanks for that talk. It's always nice to see that Python goes beyond tabular data these days. So that's always very cool to see indeed. We are going to be moving on to the next speaker. So in this case, Shivay, I'm going to ask you to unmute at the moment. And if you could unmute so we can see you in screen, I can see the slide. Everyone, this is Shivay. Take it away.
All right, thank you so much. So again, welcome everyone to PyData Global 2021. I'm Shivay, and I'm going to be presenting a talk on using TensorJS converter to be able to convert Python-based machine learning models into JavaScript-based machine learning models. And a very quick introduction about myself. I am currently a TensorFlow.js community working group member and also doing sort of code mentor for TensorFlow and MediaPipe. If you want to connect with me, you can connect me on how to develop on Twitter. Now, first of all, the most important origin of TensorFlow.js itself. So it originally started out as a deep learning.js library, and this was built as an open source library by Google TensorFlow team. And the most important thing is that we want to convert Python-based models into JavaScript-based machine learning models. And the need for that was that a lot of times creative professionals or developers who might be working on web development might not necessarily know Python or machine learning. So to be able to actually just utilize machine learning models in their applications, we can allow for converting Python-based machine learning models directly into JavaScript-based machine learning models that can be used directly with JavaScript and with web applications. So TensorFlow.js comes primarily with two different kinds of APIs that includes the core and the layers API. And we can also build completely new machine learning models directly in JavaScript and also retrain some of the existing ones that might have been written in Python. And it also uses basically both your CPU and GPU for all the training and inference that actually takes place. And it also has support for not just on browser machine learning to be actually taking place, that is on the client side, but also on the server side by using Node. And one of the biggest reasons why JavaScript is becoming so popular is that it can actually run virtually everywhere. It could be on the browser, server, on desktop, using let's say Electron.js, on mobile using React Native, or even on IoT using Node.js with let's say Raspberry Pi. And that's what makes JavaScript so much popular in terms of its versatility to be actually used in all these different kinds of platforms. And that is why we are trying to also be able to see that either we can use some of the machine learning models that have been directly converted from Python into JavaScript, or we can also use a transfer learning to run some of the existing models to actually get trained over on your own data, or you can directly actually write machine learning models in JavaScript that you can use. And of course, all of us might be aware of what exactly is transfer learning, being able to actually just go ahead and utilize some of the pre-existing models and retrain over them on your own data to make them more optimized for your workflows that you might be having. And similarly, TensorFlow.js also allows you to create your own machine learning models. Now, basically, how we have the TensorFlow and Keras in Python. So we have essentially two different types of APIs. One is the layers API that is very similar to Keras, and then we have the low-level API that is more sort of where you can actually do a lot of different mathematical transformations, such as just write your own code of linear algebra, and that's basically the ops API. And just to understand it from a high-level perspective, we have at the top, we have the pre-built models or the models that have been converted from Python. Then we have the layers API, and at the end, we have the cores API. And you can run it both on the client side and on the server side using CPU, WebGL, and WebAssembly on the client side, directly being able to run machine learning models without having to have a dedicated server. For example, being able to host your machine learning model on, let's say, a Django-based server, directly actually being able to run on client side, or you can also run it on server side by using Node.js bindings. And this is how basically we are also able to use either some of the Keras models, or we can use TF-JS converter that we're going to be talking about today for actually being able to convert Python-based models into JavaScript models. And that's what is really the main prospect of the core and the layers API. So with the cores API, you are writing basically the machine learning models directly in JavaScript. And similarly with layers API, it's highly inspired by Keras, of how Keras equivalent works in Python. So that's what the layers API is working on. So finally coming on to the TF-JS converter, that is the TensorFlow.js converter. So let's say you have a Python-based machine learning model you have written in Python. So it could either be in a Keras format, it could be in a TensorFlow-based format. So TensorFlow.js allows you to TensorFlow.js converter allows you to basically convert those pre-trained TensorFlow and Keras-based models into a web-friendly format. We'll be just also going over what is that format exactly. And essentially what we're doing is that we can take one of your TensorFlow saved models, or the model could also be there on TensorFlow Hub. So let's say you have created a Python script that is used for creating machine learning model. You can directly just convert it into a TensorFlow saved model or to a .h5 format, a saved format, and you can directly just convert it into a model.json file that has all the characteristics of the machine learning model using TensorFlow.js converter, and directly just run it into the browser and run inference with the help of TensorFlow.js. And usually this is the input format that we'll have. So basically the command is a TensorFlow.js underscore converted, and then you provide the input format. It could be a TF saved model, it could be a .h5 keras based model, it could be a th-half based model, and then you give basically the output format of whether it is a graph based model or it's the tensor model. And then you just have to give the path where the model that you want to convert into is given. And finally, you just have to give a path where you would actually want to save the output. Again, this output would be a model.json file that has all the configurations of the machine learning model that you have just created. And these are some of the features that are actually supported by TensorFlow.js. So you can either use a safe model, you can use a frozen graph, you can use an HDF5 format, which is again a file format that is used by Keras, or you can also use a TensorFlow Hub module as well. And again, it's really simple. So just take a TensorFlow saved model or a Keras S5 model or a TensorFlow based model and just convert that into the model.json file and use that model.json file with your JavaScript or your web-based project that has been primarily built in JavaScript. So let's have a very quick demo of what we are trying to build. So over here, I have an IPython file that I have just created. I'll just quickly load it up and I'll quickly share. So basically, this IPython file essentially has my model that I've created, where I'm just taking a PIMA dataset, that is the PIMA Indians diabetes dataset, where I'm trying to find out whether a person will have the likelihood of actually getting diabetes or not. So I've just used a Keras-based model where I've taken a dataset from a CSV file, and I've just used basically a basic Keras-based deep learning model where I'm using the sequential model, and then I'm just adding a few layers on top of it, and I'm using basically the Adam optimizer and also binary cross entropy for the lossless function, and then I'm just running it to fit on my dataset that I have. And finally, once the model actually runs, we can see that basically what I've done is I have saved it into a tfjs/_model.h5 file format. And once this is done, the training takes place. Then we have a total of 150 epochs. And then what I'm doing is that I'm just installing the pip package, that is the TensorFlow.js pip package. And once I've done this, what I do is I run my command of the TensorFlow.js_converter, where I've given the input format as Keras. And then I have given the input file that I have basically after I had successfully been able to train my model, where I've converted into a .h5 format. And the output where I want to actually store it is basically the tfjs_model. So once you actually run this command, you'll basically find these two different files over here. One is the model.json file. This model.json file basically has the configuration of the entire machine learning model, where you can actually see that it's basically the Keras model, and it is converted by the TensorFlow.js converter, and it will provide you all the different model topologies, and you'll also basically generate the weights of your model by which you can see over here. That is the group 1 shadow of 1. Basically, this is your weights of the machine learning model. You can directly just now embed this particular model in a JavaScript file and start using it. So the biggest reason why we are actually doing this is that a lot of times, even if we are doing some kind of a data science project, we might be actually wanting to actually showcase it in a web-based format. So instead of directly running that Python-based like machine learning data science study that you might have done, you have an alternative to actually convert that model that you might have built for a data science study that you have made into a JavaScript format and just very easily visualize it. So without having to set up a dedicated Flask-based server or a Django-based Python server where you're running your machine learning model, you can directly convert it into JavaScript and start using it with a really interactive web application. Because on the JavaScript side as well, you have a lot of different tools that can be really used to showcase your data science studies. We have a lot of different things such as D3.js that is used for for showing a lot of different types of visualizations. So it's really just very easy to do your study of data science in Python. Then once you have done that study, you're converting it into a machine learning model, right? And you can save that machine learning model with any kind of file format, whether it's a TensorFlow format or basically let's say Keras-based model, and you can convert it into a TensorFlow model in JavaScript and start using it with TensorFlow.js. With that, that brings an end to my talk. Thank you so much for attending this lightning talk. Thank you so much.
Okay, thanks for that talk. Let's do one virtual round of applause. And I'm also, while I'm setting up the next speaker, Evgeny, I'm asking you to unmute the moment. I also just got a news article. It seems like the CEO of IKEA has just been elected Prime Minister of Sweden, which is going to be very interesting because I assume that the first thing he'll do is assemble a cabinet.
Okay, can you see it?
A live mark, looking good on my side. So one round of applause. Take it away.
Yeah, thank you. Yeah, my name is Evgeny, and hi everyone. Yeah, happy to be here. So I'm an engineer at the Open Knowledge Foundation, and we are working on the open source project called Frictionless Data. We're open data advocates, and we focus on various projects related to data standards, interoperability, and software. So I think it will be kind of like a break from data science talks here. So today I'd like to show you our new tool within our software toolbox called WiveMark. WiveMark is a Python static site generator that extends Markdown with interactive charts, tables, scripts, and other many features. The main focus of the project is data journalism, software education, and Python development assistance. For example, documentation writing or task running, instead of makefile. It shortens a path from an idea to a published data-driven portal or a software documentation site. It had been inspired by projects like Miki Docs or Wizdown, but WiveMark's aim is to generalize the idea of expressing everything in Markdown. So you just need to write your Markdown files. I think it's kind of similar to R language style and environments, and here we're just trying to bring this experience to Python. The project is really new, and yeah, we're happy to present it for first time on a conference. But yeah, feel free to file an issue or report a bug, because there are some, I'm pretty sure. So show me the code. Here's a few examples of what WiveMark do on top of Markdown. In general, it supports normal Markdown syntax, GitHub favorite syntax, and add various extensions on top, converting Markdown documents to a website, HTML website that you can publish, for example, on GitHub pages. Yeah, for example, here's a chart declared in Vega notation, which is the main notation for charts in WiveMark. And it's rendered as a chart here because of the chart label in the code block header. The same for a table. So you can have a CSV in your website, assets, and you can show it as an interactive table within a WiveMark website. You can also use Ginger templating from Python, I think you know, ecosystem, to create kind of Markdown from templates. So you have a CSV and you want to have a 100 items list in Markdown, and you just use a simple Ginger for loop, and you'll get a list in Markdown. Can be really long. It can be a list of charts or tables, so it's kind of composable. There are around 20 other Markdown extensions for media file presentation, more complex HTML using Bootstrap, and around 20 other plugins for appearance and navigation. Let me show you a real site we created for using WiveMark. It was more like a showcase, but it has some value, I think, itself. It's a no surprise COVID-19 tracker, because we just decided to use this really important topic. And it showed the default WiveMark layout, although it's just excerpts from other pages, there is a like normal right column, and it's not a real column, it's just from other pages. This portal contains various coronavirus reports and covers all the available countries, including a separate page for each country. And it took like less than a week, a few days to build and publish this project using Limework. Everything there is written in Markdown or Limework. So because you can just include into Markdown like HTML blocks, it's like you anyway can include HTML into Markdown, but in Limework it's more like it's easier to do, and it's like will not break. Charts, tables, etc. Yeah, I encourage you to explore this site anymore. There are some like really interesting sections like rolling immunity and excess mortality. And the next one I'd like to show, it wouldn't be weird if you hadn't used Limework to write documentation portal for Limework itself. So of course we did, and it's fully written in Limework, and it's navigation, search, like other interactive elements to the site, although it's just Markdown documents built with Limework command line interface command. Yeah, for example, here is we have a universe and projects in the universe section, and it's a listing created by generative templates, and the data was gathered from GitHub API. So, currently, the documentation site has around 2,000 pages, while the build time is around 2-3 seconds on an ordinary laptop, and it's kind of like a big difference for engines we used before, like Docker's hours or ViewPress for our documentation. For local development, Limework provides a built-in live reload server that speeds up documentation writing. And an important difference for using Limework is that your documentation becomes like testable. Every time you build your site, you test your documentation, your snippets, examples. Like actually, you can write like all your tests in Limework. It's something I think related to literature programming by I think David Nutt. So yeah, I think it's also, there is a software education is also great area for using Limework, because you can get your educational materials like tested and up to date. And Limework is really like easily pluggable, so it's kind of like really small, a few lines of code to start adding your like HTML or something to your Limework project. And yeah, as I said, it's new, and we're going to release version 1 by the end of this year. And yeah, please report any bugs you find. The project, yeah, really needs some feedback. Share your thoughts and ideas. It's of course open source, MIT licensed, and like yeah, in general, like collective effort of people around open knowledge and frictionless data. So yeah, I think that's it. Thanks for your time.
Thanks for that talk. Especially the YAML syntax for charts is definitely a nice little feature there. So definitely well done. That also means that we are now getting to the last speaker of this session, Nicolo, and I'm going to ask you to unmute yourself. And please start sharing your screen. Then as a final joke for this session, I just learned that someone stole my mood ring. And I don't know how I feel about that. Take it away.
Yes, so I wanted to talk about this project I've been working on at Tesco. It's an experimental project, and it's really at the intersection between, I guess, interpretable machine learning, data visualization, and also quantitative finance. So it's an interesting one. We learned a few things in this space while working on it. So I wanted to share these learnings with all of you. But first, a few words around Tesco. So Tesco is the largest supermarket in the UK with more than 3,000 stores between UK and Ireland. And data science team at Tesco really works across the board in the business, supporting departments from supply chain to transport and online. So a lot of interesting projects. We in this commodity project, trading project specifically, we wanted to provide a machine learning model to support Tesco's risk management. What does that mean? So Tesco buys every year a lot of agriculture commodities. So things like wheat, corn, sugar, soybean, and so on. And the reason is that Tesco makes its own Tesco branded products, and so of course we need these commodities to make them. Now there is a big risk implicit in this activity, which is the price of these commodities. So commodity prices are volatile, and in general are a big risk factor for retail companies. They can change for a number of reasons, from climate reasons to supply and demand problems or speculations. So for this reason, Tesco created 10 years ago a commodity team, which is basically a group of people, a group of traders and analysts who look at the commodity market and try to predict the price movements and try to predict whether the price will go up in particular. And if they believe the price will go up, they try to protect Tesco from this change in price by doing things like hedging on the market and setting price with the suppliers. Also, of course, this is quite a hard problem, predicting prices in particular. So that's how the idea of a data science solution came about. So with this project, we wanted to provide a machine learning end-to-end solution that's by searching some data through APIs about, again, whether production and price would output a probability of a price increase in the future, as well as, and more importantly, a data viz to interpret the model's prediction. So that all of these could then feed back to the commodity team as a further tool they have to make their decisions and being a bit more data-driven in their decisions. So this is the general problem we wanted to solve. One challenging part of this project was that we had to deliver fast to learn quickly. So we had relatively reasonable time to develop the model, but then we had agreed with our data provider a trial period where we could use their APIs for free. And so we had a kind of a hard deadline for having a prototype of the end-to-end solution ready so that we could make the most of this trial period, so around 1 month. So it wasn't a lot of time, and we couldn't do very sophisticated things in that short time. So we had to be creative a little bit, and that was also, I think, an interesting part of that project, that it forced us to be creative and find solutions that had to be good enough, of course, for the trial, but not the full thing. So I will focus on the data viz just for time constraints of the problem. So I'll go through all the requirements we have to meet in this trial and how we solved those requirements. And so the first requirement was, of course, the model needed to be interpretable. That was very important because our stakeholders, the traders in the commodity team, needed to really understand why the model was making a certain prediction so that they could use that prediction, trust that prediction, and then use it in their decision. So the solution we adopted for that was simply to open the black box of the machine learning model with the data viz library. We use Plotly in this case. So we generated a number of graphs. I guess the most important one was this. This is a waterfall plot showing how the prediction of the model, the blue bar, breaks down into contribution for each feature, so that our stakeholders were able to tell that this prediction is mostly driven by, for example, weather data in this region of the planet, or maybe supply and demand data in this country, and so on. And also see the sign of these features. So is this variable pushing the price up or down, and so on. And then we also added more complex graphs. For example, this one on the bottom showing, again, the same feature contribution breakdown, but against time, over the last 10 months. So again, people could see trends. There are some variables, some features that change signs, change their contribution to the prediction. At one point, they become more or less important. And all of this, yeah, helped a lot the stakeholders build their trust into the model. Sometimes they could question it, and that was useful, but at least they could question it, knowing why the model was making these predictions. And also was a great tool for us to monitor the model in production and sanity check the model. So that was a win-win. The second requirement was, of course, that this data viz needed to be accessible to the stakeholders. It couldn't just sit on our notebook. The natural solution for that, of course, would be building a dashboard, but we didn't really have time to do that, and we didn't want to spend a long time just for a trial, and the project maybe wouldn't go forward after the trial anyway. So the simple solution we found was actually quite effective. Was export multiple subplots to an HTML file. And the result looks a lot like a dashboard, so it was quite good and but much quicker than a dashboard. So in Plotly, you can use other libraries too. You can create multiple subplots where you stack different plots on top of each other, and then you simply export the figure as a HTML file. The result looks, as I said, a lot like a dashboard. So you open it on your browser, you can scroll individual text boxes for information about variables, you can zoom, you can also these features of Plotly, you can select variables and so on. So to our stakeholders, this really looked like a dashboard, even though it wasn't a dashboard. And as I said, it was much easier for us to create this quicker, mostly. The big disadvantage of this approach, of course, is this is a static file. So if tomorrow the model makes new prediction with new data, of course, this file won't change because it's just showing the data you fed in when you first created the file. So this leads me to the third requirement in the third solution. So the third requirement was this data viz needs to be promptly updated every time new data come in. And our solution here was to actually use cloud services. We use cloud services to periodically update these HTML files in the stakeholders folder. So what does that mean? So this is our final end-to-end solution. So we have this API to source data. We have our model here on the cloud, this service called Azure Machine Learning, where we do inference and we do plotting. We create this HTML file, this lands into a storage account, and then we use a new a second cloud service app called Azure Logic App that connects the storage account to the SharePoint folder and also the email inbox of our stakeholders, so that automatically this new HTML file lands in their folder. So from the point of view of our stakeholders, this is very neat. So they have this file they can open in their browser, and pretty much every day they have a fresh new HTML file with new data. They don't even realize it. It's just all happening kind of behind the scenes thanks to the cloud technology here, and kind of this creative use of the cloud technology. So yeah, that's pretty much it. So the conclusions, I guess, the take-home message I wanted to convey was that a static HTML5 plus cloud services can make a great rough and ready dashboard. That is not really a dashboard, but it's great, good enough for proof of concepts and trials. And then you really set this up in a day. And then if the business is happy with the result, then you can crack on with the actual dashboard and invest time on a server and so on. Our project was successful in that we stakeholders' feedback was good, the model's performance was good. So the business is now deciding whether the commercial benefit is good enough to move on. And if they decide to do that, we'll, as I said, migrate the data viz to a proper dashboard now that we have time, explore more complex architectures and more commodities. And that's it. I will just conclude saying we are hiring at Tesco. So if you're interested, get in touch on the website, Tesco Careers, or get in touch with these people. Thank you.
That was a really like the chart you had back there. Actually, the I can definitely imagine how drift is easily detected there. But with that said, this was the final speaker in our lightning talk series. So what I would like to do is just end with a cute little poem that someone shared on the PyData Global Slack. Roses are red. I feel the burn. I used a deep learning tool. I should have used scikit-learn. I thought it was kind of a cute one to end with. Thanks all the speakers for sharing their ideas, and thanks to all the listeners. Once again, thanks everyone, and see you around the conference.